Welcome to the ChIPSeq workflow tutorial of Sangenix. In order to launch the Sangenix application, type the URL in the address bar of the Mozilla browser and press Enter. The Sangenix login page will appear. Log in using your registered username and password. This will bring you to the Sangenix home page. To run a ChIPSeq predefined workflow, click the arrow corresponding to ChIPSeq in the Actions column. A Save Workflow Execution dialog box will appear. Type a name for the workflow execution, select a suitable organism and click OK. The workflow canvas for ChIPSeq will appear. This canvas displays all the workflow processes that are applicable to ChIPSeq analysis. The first step in the ChIPSeq pipeline is quality check and adapter trimming using the composite tool FastQC CutAdapt. This step provides a quick impression of whether the input data is error-free before initiating the downstream analysis. Following quality check, mapping of reads to the reference genome is performed. The aligners available in Sangenix for this step are bowtie, BWA and top hat. A SAM file is generated after mapping. This is converted to its binary format, BAM, using SAM to BAM process. In case of replicates, BAM merge step is executed to merge the multiple BAM files. This enables processing multiple files together as a single file and also decreases the post-processing of data, which may happen if you have individual BAM files. Further to this step, peaks are called using max in the peak calling step. If you want to configure parameters for any particular process, click the appropriate process box. For example, upon clicking Mapping, a Property Editor box will appear. Since this is a predefined workflow, default tool and parameters of the process tabs have already been set. Depending upon output, these can be modified by you. Click OK after the parameters have been modified. This brings the user back to the workflow canvas. Parameters for each process can be modified likewise. Once you have set the parameters for each process, click Next on the workflow canvas page. The Input Properties page will appear. This page is divided into two sections. On the left is the Input Properties section and on the right is the Input Summary section. Information can be updated in the Input Properties section and you can view the updated information in the Input Summary section. Click Add Experiment to enter the details for your current experiment. In the Input Properties section, user is required to enter appropriate information in all the mandatory fields. At this point, user can choose the parameters which are specially designed for the input files. For example, you can see highlighted here, user can select the length of the reads to be considered for the analysis, quality cutoff, duplicate removal threshold, and so on. Select your treatment file in the field Max File Type and upload it by clicking Browse. A Browse Files dialog box will appear. Select the appropriate treatment file and click OK. You can now see the browsed treatment file in the field Read File. Click the Add to Summary button. The uploaded treatment file will now appear in the Read File Summary tab of the Input Summary section. Likewise, select the option Control File in the Max File Type field and browse it in the Browse Files dialog box that appears. Browse the control file and click OK. Once you have clicked on Add to Summary, you will now observe both treatment and control files in the Input Summary tab. To view the file properties for any uploaded input file, click View. The File Properties dialog box will appear. If you wish to edit properties for any uploaded input file, click on Edit. Make the required changes in the Input Properties section and click Add to Summary. This will update the information for the uploaded input files. Now, to upload the reference file, click on the Other Files tab. Tick the checkbox in case you wish to use an annotation file for the analysis. Select the appropriate reference file. This will automatically update the annotation file field and then click Add to Summary. The uploaded reference and annotation files shall now appear in the Other File Summary tab of the Input Summary section. Once you have successfully uploaded the input and reference files for the ChIPSeq workflow, you are ready to execute the predefined workflow. Click Run. Alternatively, you can also save the input and run the execution later. Upon clicking Run, a dialog box appears with a message, Workflow processing has been started successfully. You will automatically be redirected to the Workflows page, which will give you the exact status of your execution. For example, here, the predefined workflow that we executed displays the status as validating. To view the updated status, click the refresh button intermittently. Now, to customize a workflow, go to the predefined workflows page under the Workflow Templates tab. Upon hovering over the More link against ChIPSeq in the Actions column, click Customize. This will bring you to the workflow canvas. Select a process for customization. For example, if you want to customize the mapping process, click on the Mapping Process box. The Property Editor page will be displayed. You can see here that a drop-down list in the Tools field allows you to select what tool you want to run the ChIPSeq analysis with. This is unlike the predefined workflow where default tools have already been set. Once you have selected the tool and edited the parameters, you click OK. Save the customized workflow with an appropriate name and click OK. You can view the customized workflow that you just created under the Custom Workflows page on the Workflow Templates tab. Upon hovering over the More link, you can execute your customized workflow from here by clicking Run. Alternatively, you can again alter some tools and other selections by clicking Customize. Here we will execute our customized workflow by clicking on the Run option. By clicking Run, a dialog box will appear called Save Workflow Execution. You save the customized workflow execution with an appropriate name and select the suitable organism for which you want to run the analysis and click OK. This will bring you to the Workflow Canvas page again. This will contain processes with your custom selection. For example, BWA that we selected under Mapping. Upload the treatment and control files as was explained before. Likewise, upload the reference file and the annotation files. The information can be seen in the Other Files Summary tab. And once you are ready to go, click Run. You can check the status of your run under the workflow executions page. The status can be seen here. For example, the custom workflow that we just executed displays the status as validating. Let us now discuss the result dashboard for the ChIPSeq workflow. Sangenix offers a graphically enriched and an interactive result dashboard. To view the results for an executed ChIPSeq workflow, click the View Results link on the Workflow Executions page. This will bring you to the graphically enriched dashboard in a new tab. This panel is comprised of 6 views that are based on the false discovery rate, in short, FDR value. This is the value that the peak caller assigns for each peak. You can select an appropriate FDR value from the drop-down list. The first view that you see here is the tags plot view. This view displays the density value of reads in the treatment and control sample at a given location. Another view provided by Sangenix is the scatter plot view. It displays read density at a given location. Once you hover over a point in the scatter plot, density values will be displayed for the treatment and the control sample. This view will instantly help you know whether the ChIPSeq experiment that you have executed has worked or not. If a control sample is not provided, this view will not be displayed. Moving on to the next view on the dashboard, which is the region-wise distribution of peaks chart. This chart shows the distribution in the 3' downstream, genic, intergenic and 5' upstream region. Upon right-clicking on any section in the pie chart, the corresponding gene ontology information is updated in the next chart, which is geo terms for peaks. For those peaks that fall under intergenic region, geo term is not available. The geo term for peaks pie chart displays the functional role of genes where peaks are enriched. Moving on to the next pie chart, which is the chromosome-wise distribution of peaks. This chart displays the percentage of peaks identified on each chromosome. The tag-wise distribution of peaks displays the number of tags present in the peaks, while the fold enrichment of peaks is displayed in the chart called fold enrichment distribution of peaks. When you right-click on any section of any chart except the tags plot, you can go to the interactive genome viewer in a new tab. By clicking on a particular row in the table, corresponding genome region is expanded and details for the same can be viewed in the browser. With this, we conclude our video tutorial on the ChIPSeq workflow in Sangenix. Hope you enjoyed it. Thank you.